to look at complex fractions in this section. A complex fraction has a fraction inside a fraction. And basically, we cannot leave an answer like that. We have to clean it up. There are two techniques that could work for this problem. One is that we could write it across as divide and then change it to multiplication. That only works okay on this problem because these are monomials, so it's not going to be a big deal to do that. So we could write it across, divided by 4 over 6x, change it to multiplication, and remember you invert the divisor. You can cancel on your diagonals, and 4 will go into 12 3 times. So this simplifies to 3 over 1 or 3. That technique works fine here. The other technique is to multiply on the top and the bottom of this big fraction by the LCD of all the denominators. So method 2, same problem. Is pick the LCD. 6x is the common denominator. We'll multiply by it up here and down here. That way we have really multiplied by 1, which is always okay to do. This will cancel this denominator, and it will cancel here, which leaves us 12 over 4, which is 3. All right, next I picked problem 3. So we have 5 over x minus 3 divided by x over x minus 3. You also could use both methods on this particular problem. Normally method 2 is the best one for these problems, but this one you could do either one because your denominators are going to match. So if you wrote this one across, you have 5 over x minus 3 divided by x over x minus 3. You change to multiplication, and you invert the divisor, and then you cancel, and then multiply across. So our answer is 5 over x. If we go with method 2, it says find the common denominator of all the denominators. So this one is method 2. And the common denominator would be x minus 3. So we would do an x minus 3 up here and an x minus 3 down here. And these would cross off and you get the same answer. So for these two problems, either technique could be used. And we'll just check to make sure we're good. All right. Once you have addition or subtraction within either the numerator or the denominator, you should always go with method 2. So this one is problem 4. We have 3 minus 8 over x over x plus 5 over 6x. So we'll find the common denominator for everything here. These two are over 1, so we can ignore them. So we're looking at x and 6x. You have to cover every type of piece. So we're going to need a 6x. if you multiply that by the numerator and denominator, it has to be every term. I go ahead and write it beside every term, so I'm actually just distributing it through. So this one gets a 6x, this one gets a 6x. This one gets a 6x, this one gets a 6x. And then you clean up what you can. This one will wipe out. This one, the x will wipe out. And now we'll put it back together. So we'll multiply across. So we have 18x minus 8 times 6 is 48 over 6x squared plus 5. Right, nothing we can do with that denominator. You could factor a little bit here, but it's not going to end up matching this whole thing. So there's nothing to do, even though we could factor out some. We could factor out a 6, but we can't factor the 6 out on this one. So they're not going to match. So just leave it as is. So we have 18x minus 48 over 6x squared plus 5. Good. So problem 5, we have 4x squared minus y squared over xy. The whole thing is over 2 over y minus 1 over x. Excellent problem for this technique. Your common denominator is going to be an x and a y. That's what this one has. This one has one of them. This one has one of them. But you want the most. So you need an xy. So do xy up here. Xy times each piece. You have to use the whole thing. We're just really distributing it through. Right? And this will clean out. This one, the x will clean out. This one, the y will clean out. So what we have left is 4x squared minus y squared over 2x minus y. Now, you do have to factor to see if these will reduce, if they'll factor. Your numerator is a difference of squares. So it is 2x plus y and 2x minus y. Your denominator does not factor, but we did get some things that will divide out. These two divide out. So our answer is 2x plus y. And we don't have to have that parentheses anymore since we're not going to divide anything out. Oops. Good. All right, question 6 is also an excellent question for this technique. 4 over x plus 5 over x squared over 16 over x squared minus 25 over x. So the first job is to figure out your common denominator. While all of these have x's, you have to go with the highest one, which is an x squared. So you're going to multiply everything by x squared. And you're going to clean up. So these go out. One of these goes out. These go out. And this one goes with one of these. So now we'll put it back together. So we have 4x plus 5 over 16 minus 25x. And this one does not factor. Our exponents are 1. All we could try is a GCF, so there's nothing we're going to be able to do there to help us out. So 4x plus 5 over 16 minus 25x. Good. All right, we'll try one more. So we have 2 over 6 minus x plus 3 over x minus 6 over 4 over x plus 2 over x minus 6. So this one is involved. We're going to pick our LCD. And these two are opposites. Remember that you could use either one of those for the common denominator. You do not need both. So let's choose x minus 6. We also have to have this x because it is a monomial. Right, and that's what we're going to multiply by each piece. So we have x times x minus 6 by each one. All right, and we'll clean up what we can. All right, this one we have to just be a little careful on. Remember that this is equal to -1. You could factor your -1 out here. The -1 will be left, but we'll put it on the top. So this piece and this piece simplifies to a -1. So we still have that. So now we clean up and we have -2x plus 3x over 4x minus 24 plus 2x. So we have some things that go together. This gives us just x on the numerator, and this gives us 6x minus 24. We can do a GCF there, so we'll take out a 6, and that leaves x minus 4, but that did not help us. It didn't get us an x to the outside. So actually we could have left it here. You could have either form here for your answer. You have to think about that reducing, but it doesn't always reduce. So x over 6x minus 24. Good. All right, we'll stop there.